All right. First thing I want to ask, any questions from last time? Okay. Just a little update. There is none. Okay. I hardly had time to do anything to update stuff. I did get some things done, but nothing you would be able to see. And from what y'all said, we were somewhere here in the research paper. Let me start scrolling down, and you tell me where to stop. What were we doing? Where were we in this process? What's that?
He told us go ahead and pick something to like start thinking about what we're talking about.
Say that again.
Go ahead and find something.
Oh, okay, right at the very beginning, sort of. Okay? Write on a piece of paper your topic, that kind of stuff. Did we go over that?
No.
We didn't? Oh, okay. Not about phone numbers, that kind of stuff? Yeah, I did talk about that. Okay? So that's, phone numbers aren't listed here. That's just something I said you can do otherwise. Did I talk about how many sources, where you can get the sources? Okay. So, I think we're somewhere right about here. Okay. Continuing talking about the research paper. You'll need to have at least one outside source. Now, the book is not an outside source. The book is a great source for ideas for the paper. They'll have little blurbs about people. They'll have little blurbs about theorems, about things that have happened, that kind of stuff. But that can't be your source for the paper. It can be the source for the idea for the paper, but not for the paper. Okay? Now, so where do you find your sources? And by the way, one or more sources. Got to have at least one. Two or more are better. Can I get your name, please? Second? One more time. Woodall. Is that what you said? Okay. Chris Woodall. Got it. My hearing is so bad. Sorry about that. Okay. So we're picking up where we left off last time with the research paper. So two or more are better, outside sources. Where can you find these? Books, journals, articles, newspaper, magazines, just about anything you can find in the library that would have address your subject matter that you've chosen to write on. That's all legitimate. And I allow you to use legitimate sources found on the internet. Now that can open huge cans of worms, because in my mind, the internet has it's a fantastic thing. I mean, it is incredible what it does and allows you to do. But there are at least two really major problems with it. One, at least, and I think way more than half of the stuff on the internet is total garbage. Okay? Total garbage. People can put anything out there they want to, and they can make it look as true and reasonable as they want to, but it can be total garbage. Okay? I'm not talking about you. Okay. No. Okay. Let me guess. Jake? Okay. Good. All right. Good deal. Everybody that was here last time is here today, plus one more, so that's good. Hopefully the next couple of people will show up as well. All right. So, back on the internet. At least half of the stuff, I think way more than half of the stuff out there is total garbage. The second big problem is sometimes you don't know which half, okay? So you have to be very, very, very careful with the internet. If you have any doubt about the legitimacy of an article, it's probably a pretty good idea that it's probably not good. But if you want to run it by me, bring it to me. I may look at it and say, no, that is fantastic. That's good. I've heard of this guy. I know what they talk about here. That is right on the money. Or, no, whoa, see if you can find something else, okay? So, you can use the internet. Be careful. The book cannot be your source, okay? It can be a source of ideas, but not the source for your paper, okay? Now, your paper needs to be at least one word processed page of text. Now, what do I mean by one word process page of text? Let's say, and you don't have to do this, but a lot of students do, they have some sort of format that they use that has a header here and something here and stuff. They skip a few lines, have the title, the triple space, and then start typing somewhere down here. So what's one page of text? That's going to go to the bottom of this page, and then on the next piece of paper, it's going to start at the top wherever that was and come down and go at least that far. That's a page of text. Because just because you use some big header and stuff, that doesn't mean you can do a shorter paper. Or just because, yeah. So you get the general idea. I want at least one page of text. Okay? Now, and I want it double spaced. This is single space. Don't give me a single space paper. Double space. And that counts as just one page. So it's not that much. Okay? The reason I want it double spaced is it makes it easier for me to read and make comments and put annotations by it. It's really hard with single space. Okay? And I want 12 pitch and 12-point font. If you really want to go smaller font, you can, but not so small that I have to squint. So 9, I think, may be too small. But I sure don't want to see anything less than that. Go for 12 if you can, but nothing bigger than 12. No 26 or 15 words fill up the page and say, I'm through. No, you're not. So don't do that. Okay? The font is up to you as long as I can read it. Don't get fancy and curly cute and that kind of stuff with me. If I have trouble reading it, you're going to be losing points because I can't read what is out there. So there's lots of great fonts. Go for whatever you want to. Try to keep the paper less than 2 pages. Now, that's not a requirement. That's a suggestion. I don't want this. I mean, a good 5-paragraph essay is probably going to stretch into 3 or 4 pages. You don't have to go that much, okay? If you want to, you can. If that's what you're used to writing, perfect, fine. But I just want you to get an idea, follow it up, find the sources, write down, communicate to me that you understand and are fired up about this topic. That's what I want, okay? This isn't something you're going to publish or anything else. You're going to do it well, but it doesn't have to be. So shoot for 1 to 2 pages of text. Now, if it's anything less than 1 page of text, you're going to lose points. If it's anything greater than 2, you're not necessarily going to lose any points. I don't take off points for it being too long, directly anyway, okay? If it's a good paper, I'm going to enjoy reading every page of it, even if it's 3, 4, or 5 pages. I don't care. If it's a good paper, I really do enjoy reading your work, okay? Now, I've had a few tutors. I've been doing this for well more than 15 years, probably 16, 17 years. Just about every class, every term, papers. So I've seen a lot of papers. And a few times, maybe 3 or 4 times, but I don't think any more than that, I've had some student that the only thing I can figure out is they know they're writing a lousy paper and they're going to replace quality with quantity and think they're going to impress me. It's not going to work, okay? Because here's how I grade your work. You turn in a paper to me. When you turn it in to me, it's a 100-point paper. Then I start reading it, okay? And if I find things that are wrong or all of these things, you start losing points, okay? So, you turn in a 15-page paper that's a really lousy paper. You have a spell check. You didn't grammar check. You know, bad structure. All this stuff is in there. Guess what? Losing points, losing points, losing points, losing. You know, the longer it is, the more papers, the more points you lose. So don't go for that. Now, if it's a great paper, you're not going to lose that many points anyway. You're going to get a good score, okay? But a lousy paper, it don't irritate the butt out of me. I read every word. I do read it all. And that really is irritating to have to read a long thing. All it is just more and more garbage. So please don't do that. It's not going to help you. Okay. So, enough on that. You can use any format you choose. Most English classes teach MLA, which is Modern Language Association format. If that's what you're used to, that's what you like, fine. I'm fine with it. A lot of professional social sciences and some science organizations use APA, that's American Psychological Association. They came out early with a fantastic, simple, straightforward, but very precise format, and lots of people say, can't beat this one, I'm going to adopt theirs, you know. So if you want to use that one, it's fine. I'm a member of several professional organizations. I swear, I think every one of them has their own format. Yeah, I don't know why they do that. You can choose any format that you know, you like, you can obey. The main thing is you be consistent. For instance, if you start blocking paragraphs, block all your paragraphs. If you start indenting paragraphs, indent all your paragraphs. If you start in one font, stay in that font, okay? I have seen font changes in the middle of a word and in the middle of sentences, and it's just sloppiness. I don't know why that was done. There's no purpose. Now, I can understand italics for emphasis or bold for emphasis, but you just emphasize that part and you go back to the regular. Same thing you were using before, right? Okay? So consistency is important. Also, now, I don't see this often, but I've seen it often enough that I want to mention it to you. I've seen someone refer to a source, and that first source they refer to, they open parentheses, put the author's last name, comma, year of publication, close it, and that's how they refer to the work. So I can take it in the works cited, bibliography, whatever. But somewhere down here on the next page or later paragraph or something, they refer to a different thing, but it's a similar thing, either a book or similar journal article or something, but something similar. But they open parentheses and put title, comma, year of publication, or page number, or something like that. I say, wait a minute. That's a similar citation, but it's done in two different formats. Now, I have a good idea of what happened, okay? The person up here reading along used the source, used it well, and just happened to look at the source and see how they did their citation. And they did their citation just like their source did. Makes sense. But down here, this citation here happened to be using a different format. So they use a different format for this one. No, that's not how you do a paper. You choose the format beforehand, and you do all your citations. It doesn't matter what they use as their citations, you use the one that you're using. Okay? Doesn't happen often, but I have seen it, so I try to now, spelling, sentence structure, grammar, all those kind of things that English teachers look for, big time. I see them too. Now, I probably don't take off as much as English teachers do, but they do lose points. But not just that. Content matters, okay? So if you have inconsistencies, you lose points for those as well. I'll just give you a couple of dumb examples, maybe. And it's funny, but I've seen it happen before. Someone starts a paper, writing maybe on a person, and when they first mention them, I don't know why a lot of places do it. They put parentheses, the year of his birth, comma, the year of his death. Then back here on page 3, they have that he died in a different year. Now, that wasn't that long a paper, so it should have been the same. So, be consistent. Keep up. I've seen this with dates too. Something about Isaac Newton, and they say 1943. No, Isaac Newton may have been 1493, but not 1943. So be consistent. Make sure your content is consistent. Okay? I've read dozens of papers on Pythagorean theorem, and every now and then I'll have one that states it totally wrong, or in trig. They'll tell me about the law of sines, but actually give me the law of cosines, and I'll, think about what you're saying here. So, content matters. Now, when is the paper due? Technically, not till the last day of class. Now, that's not the last day of finals. The last day of class is the drop dead last time you can turn in the paper. Do I want you to turn it in that day? No. I want you to turn it in as soon as you can. Now remember I said, give me your paper topic on a piece of paper, and all that by phone numbers too. The reason I want you to do that either today or next week is I want you thinking about it today or over the weekend or sometime. So you already start thinking about it, start thinking of sources, looking for sources, start your paper as soon as you can. Okay? You'll never have more time to work on a paper than you do right now. Any of you already got a paper, a project, or something due? Maybe 2 things? Wow. Now you have 3. Okay? But guess what? In 3 weeks, I could ask the same question. Everybody will hang up bunches of things. Okay? So you don't even know how many you got. You lost track. Okay? So start now. Start early. And if possible, turn it in early. This is not precise. It's a gross generalization. But like I said, I've been doing this for well over 15 years. Taught every term, every class, time. Taught, like this time I've got 7 classes this term. Not all terms do I have that many, but I've had terms with 8. Lots and lots. And then classes are usually bigger than this. So I've seen lots and lots of papers. And this is a gross generalization, but it fits. Usually the papers that come in earliest in the term, usually, are my best papers. Good papers come in. And as the term goes on, the quality just sort of seems to decrease. Okay? And those that come in that last day of class usually are some of my worst papers. Now, I've had some real dogs at the beginning of the term, and I've had some great papers coming at the end. But the general trend is downhill. Why? Because people get started early, got more time, do a good job, turn it in. Okay? Why down here? Oh, I have a paper due tomorrow. Okay. Forget the proofread, not even spell check. Nothing done, I can tell. And I see that a lot at the end of the term. So that's why that's true. Now, so last day of class is probably going to be the first Thursday in December. I don't know that for sure, but sometime around there. That's the drop dead date. Last date you can turn it in. You turn it in the next day, the next week, finals week. I'm really going to like that. Okay? You're going to lose points. Okay? Because it's due by the end of the term. That's the stick. Here's the carrot. If you turn in your paper this month, and you only have next week to go, right? If you turn it in the month of August, 4 bonus points. Whatever you score on that paper, I add 4 points to it automatically. Okay? If you turn it in the month of September, 3 bonus points. October, 2. November, 1. That first week in December, you can turn it in, you just get your score. Okay? After that first week, or whatever the last day of class is, negative point. You start losing points. There's the carrot with the stick. Okay. Now here's one thing I require. I don't know anyone else that does, but I want to see this. When you submit your paper, please attach a single page from one of your sources. So let's say it's a book, a journal, a magazine, something you got out of the library. Take it over to the copy me a single page from that source. Okay? If it happened to be something you got off the internet, print me a single page from that source. Just one page. I don't need a page from every source. I don't need the whole source. Just a single page from one of your sources. Now, remember one of the options was, I talked about this last time, you could choose a computer application like a YouTube video or something that explains something that we cover in the book, but it does it so much better than the book does, or I do. I'm not offended, but you can do it. That won't have a page you can print, right? I don't guess it will. If it doesn't, just give me that link, okay? Which you probably would anyway as you're source cited, but give me that link. Now, if you compared it to something else, you can use that as your page. Okay. Any question about the paper? All right. Get started early, get them into me early, get those good scores, those bonus points on the table, take advantage of them. All right. So let's close that. Now, before we get started in trig, there's one other issue that we need to deal with because it's important. Okay? And that issue is safety. Now, we're not going to be doing anything that you have to have special safety things in mind. but it's overall safety. 3 areas I want to address. I want to do it really quickly, so I need your help. What is one area of safety you always have to keep in front of your mind? Think of something. Anybody? Fire. Exactly. Now I'm going to expand that a little bit. Anything inside the building that's hazardous, like chemical spill, noxious fumes, fire, something like that. Let's take worst case scenario of that. That would be my computer explodes and it starts burning the papers that are near it and the desk, the varnish on the desk, and then the wood of the desk. What do we do if that would happen? Anybody?
Walk out the door.
Okay. Yeah, we leave the building, leave the room, leave the building, and let everybody else burn up their trash, right? Uh-oh, we left out a step, didn't we? What else do we need to do? Yes. As we're leaving, I would like 2 of you, because I think the buddy system is good, to go and get to the nearest fire alarm. So my next question to you is, where is the nearest fire alarm? Here is a map of this building, of this floor of this building, second floor of this building. Here we are here. There's a stair, half flight of stairs there, hallway here, hallway here, hallway there. Where is the nearest fire alarm? Exactly. Guess what the answer is? There is no fire alarm anywhere on the second floor of this building, because this is the old part of the building built before the fire alarms were part of code. So therefore, you can't pull a fire alarm anywhere close to here. Where the closest one is, you go out the door here, hang a left, go down that little half flight of stairs there, just past the restroom to that corridor, then you take a right, you go across through the double doors and the financial services right in front of you. That's the newest part of the building. Now, the reason it doesn't show up here, this is the second floor. You go across that corridor, that's first floor. Strange, right? Okay. The first floor beneath here is 1 floor down. Okay. So that's why it doesn't show up. But as soon as you come through those double doors, there'll be a fire alarm immediately to your right and another one immediately to your left. You'll see them both, whichever is most convenient, easiest to pull, go pull the fire alarm. Okay? So, we pulled the fire alarm to notify everybody in the building. Anything else we need to do? Excellent. Now, actually, there is a number better than 911, and that's campus police, the emergency number. Do any of you have that on speed dial on your phone already?
I got a speed dial.
Okay, but you have it on that app. You have the Lawson State app. It's right on top of the Lawson State app. You got it somewhere?
Yeah, I got it. It's 205-426-3654.
Okay, let's say that again. Wait until I can sit down and write it. Let me see if I can do that. Oh man, not gonna let me hear. Hold on just a minute. Time's a wasting, people. We're burning up in here. Okay, okay, let me get my pen activated. All right. Say it again. 3654. Okay. Is that Lawson State Police on this campus or is that Birmingham? Bessemer campus. Fantastic. Also, if any of you have that, what do they call it? The Lawson State app. They say right at the top of that. I don't bring in my phone to work, to class, so I don't want it going off. So it's down in my office. No, actually, I left it home today. But anyway, so I can show it to you, but that's the number. Now, if you don't have that, 911 is real quick to do. But you see, if you call them, they'll get in touch with 911 immediately. They probably have hardwired to it. But that way they get involved early. They don't want the alarm going off and the emergency responder coming out and say, "Where's the fire?" And they go, "Well, it beats me." You know, that makes them look sort of bad. So if you can, call campus police, and they'll get in touch with you. Okay, so you've done the 2 first things: alarm and campus police for 911. What else might we do, especially if the fire's in this room?
Can we leave now?
Say again?
Can we leave now?
Yeah, y'all have been leaving, but there is one other thing before everybody leaves that would be a smart thing to do. Burning up my desk here.
Right.
Okay, yeah, for sure, always, without ceasing. Okay. We're just going to let it burn?
Oh, fire extinguisher.
Fire extinguishers! Oh my, well, where's the nearest fire extinguisher?
I thought the firefighter was going to do that.
Oh yeah, but I'm not going to wait for that. That's my papers up there.
Get your papers.
Okay. Where's the nearest fire extinguisher? Okay. Right here where I'm standing, less than 5 feet. There's the closest fire extinguisher. You can't get much closer than that. So I would really like to ask one of you, or I can pick one, to go out there and, okay, you guys, and maybe you gals too, but you guys, I know some of you thought, man, that would be so neat to break that glass, wouldn't it? You know? No, you haven't thought that out. I bet so. Yeah, I thought so. Okay. So, someone go get the fire extinguisher. Now, if you do, be careful. Don't cut yourself on the glass. Otherwise, I'll go get it. And I can operate the fire extinguisher. I can help put it on. And you're absolutely right. The rest of you start leaving us. And in fact, if it did start in that room, as soon as you hear that fire alarm, we start leaving. Where do we go? Okay, that's also important. Well, you go out the door here, hang a left, go down that little half flight of stairs, hang another left at the very bottom of the stairs, go down one more flight, and then you head out of the building. Out, directly out. Not along the building, go follow the sidewalk, because if the fire creates an explosion, it's going to blow glass that way. You don't want to be under where the glass is going to fall. You want to go straight away from the building, at least 75 feet. That puts you down in a nice grassy area down there, but you don't stop there. Used to, that's what we do, but now they want us to go. Now here we are in this corner room right here on this map. You go into the hallway, down the stairs, out the building, and go down to that parking lot, right between here and the Ethel Hall building. Okay, that parking lot there. Stay in a group. Do not want any of you think, hey, fire building's on fire, no more class today, I'm out of here. No, you may think it, but you don't do it. Here's the reason why. Now, in one of my classes, I can't remember which one of the guys had knee surgery over the break. He's in a big brace on his knee, but he moves around pretty well. Okay? But I'm going to be the last one out because whoever's the slowest, whoever might be having difficulty, I'm going to make sure you get out of the building. Okay? The two that went down to do the fire alarm, you come out that same door, that's the closest one for you. We stay together as a group because as I go, I'm carrying the roll with me. It'll be in a roll book by then, hopefully. And I'm carrying it with me, and when we get down there, I'm calling roll. If we can't account for everyone who was here earlier, that means we assume someone's left in the building. So therefore, myself or some fire professional has to risk his or her life and health coming back into a burning building, noxious fumes, chemical spill, whatever, risking all that, trying to find you who got in your car and left. Okay? So don't do that to anybody. Stay together. Joey, we're sure we've accounted for everybody. And you usually wait until they give us word what's going to happen next. Okay? Don't be taking off. Okay? Any questions? There'll be fire, chemical spill, noxious fumes, anything. Fan room exploded, whatever. That's what we do. And when you're leaving, you go slow. You don't do slow, but you do calmly. You don't run. You don't want injuries that you're having to deal with as you're trying to get out of the building. Take it carefully. Take it slow. Be controlled. And leave. All right. There's one type of safety that you need to keep in mind. Where do you go? What do you do? What do you not do? That kind of stuff. What's another kind? Say again?
Severe weather.
Yeah, severe weather. If we hear that alarm go off, and boy, you can hear it from here too. If that alarm goes off, what do we do then? Any ideas?
Safe place in the
Okay, where's that?
I saw someplace where it was like a gun. Never mind.
Okay.
I don't know.
Here's the general rule. You probably do know it. You just not think about it well. You go low and interior. That's what you think. Low and interior. Where is that from here? Well, you go out the door, hang to the left, go down that little half flight of stairs there, hang to the left at the bottom, go down that flight of stairs, and you don't go out of the building. That's not where you go. Don't say, oh my cat's outside, I need to go home and get her in. No. Cat will take care of herself. She has plenty of life. You don't. The worst place to be in severe weather is in a car on the road. Do not even think about going outside in severe weather. Okay? Certainly not in a car. So you go down those stairs and then you go interior. All right. Now the first floor, this is the second floor. First floor is a lot like this. And when you go down that flight of stairs there, you come out and the restroom's right in front of you. Believe it or not, those restrooms are a very stable, safe place to be. Why? The walls are close together and lots of corners. That's the greatest strength of the building. The walls, especially the corners. And the closer the walls, the more the strength. It's just maybe you don't want to spend the next couple of hours in a restroom, but it is a safe place. Okay? There are actually, on the first floor, 2 more steps down, and right past the restroom there's a little office. It's the academic dean's office. And again, that's interior and small space, close walls, greatest strength. The trouble is she's very seldom here on campus. Now, she's been here a lot this week, but she very seldom is here. Occasionally the associate dean will come over and he will use that office, and occasionally someone else from Birmingham campus will. Most of the time the office is locked, so don't break the window or anything just to get in there. If someone's there, they invite you in. Now let me tell you something. Remember I said across this corridor from the second floor is the first floor. That's the new part of the building, newest part. That's where the fire station is, right? Beneath that is soil, okay, or structural elements, okay? There's no crawl space. That sits right on the ground. That means down on the first floor, this back wall here is backed up with dirt, with soil. It's solid. There's no place for it to go. So it really can't collapse on you. So therefore, in any of these places I'm talking about, that back wall is a very strong structure. Okay? So the dean's office. The next one is room 160, which is a developmental math classroom. I don't know if any of you attended that one. It's sort of a big space, so don't get in the middle of it. Again, the walls are best. That back wall is the very best. The corners are even better. Okay? The other walls are okay, but that back wall is really safe. So room 160 is down there. It's just about underneath that classroom better. Then you go through glass doors on the hallway, and you're into the library, and to the immediate right is a computer room. Now that's a smaller room, even better. Back wall, excellent, good strength there, and the corners, great. And any wall is okay. Okay? Now, just past that one, there's what I call the reference room. It's a little bit bigger than the computer room, not as big as the classroom, but that's okay, especially that back wall. The only disadvantage of that is the bookshelves. And if it's a really strong tornado and things start shaking around and stuff, that some of those could fall. So stay away from the front wall. The back wall would be better. Now, I've ignored maybe the number one choice. Number one choice may be the hallway. Because the walls are relatively close together. No corners, that's the disadvantage of the hallway. But the main advantage of the hallway is if there is severe weather, there is a very good chance the power goes off. And if you're low and interior, you're trying to stay away from windows. And by the way, if you go into the library for either the computer room or the reference room, don't go any further. Because any other room in the library is an external room. And you don't want to be in an external room where there could be windows or a wall that can come, a tree can come into it or whatever. So stay away from the external room, interior. But low and interior, you could be in the dark. The restrooms, no emergency lighting. The dean's office, no emergency lighting. The classroom, no emergency lighting. None of those places emergency. The hallway, yes, emergency lighting on both ends. So that's probably where you would be. Okay? Now, if the power doesn't go off, those other places are fine. Or if the power does go off and it gets pitch black dark, all you want to do is sleep anyway. You can go to one of those rooms, sleep near a wall. Okay? Whatever. I don't know. So that's where we go in case of emergency. Oh, by the way, I will be the last one out because I'll be going with the slowest person down. I'll be following y'all, and we'll get at the bottom. I'll be following roll. If we can't account for everybody, myself or someone else has got to go up looking for you. So please don't wander off somewhere, especially try to get off. I'm going to beat the storm home. No, you can't guarantee you're going to do that. Those things can be very powerful and very fast. Were any of you in the area? What was it, April 11th? Second? Yeah, okay. 2011, that's what it was. Yeah. That was amazing. That was just unbelievable what happened in the state. No one should have been on the road anywhere except emergency vehicles. All right, so we've covered internal emergencies, fire, chemical spill, external emergency, severe weather. One other thing that we have to be aware of. And in the past, I never, ever even thought about it. But currently, you got to think about it.
School shooting.
Say again?
School shooting.
School shootings, you're absolutely right. Now, as far as I know, and can remember and heard, there's only been one community college that's had a school active shooter. There may be more, but that's the only one I've ever heard of. But there have been many universities, multiple high schools or grammar schools, and then lots of other places too. So nobody's immune to it. Now, if you hear pop, pop, pop that sounds like it could be gunfire, guess what? I'm hard of hearing. You will hear it before I will. So please stop me and let me know. What do we do? What do we do?
Well, we can't lock the door, so I mean, we can.
Okay. That's a good thing. That's a very good thing.
Barricade.
No, actually, I have keys. Now, the trouble is, I can't lock it from inside. There's no keyhole. There's no switch. I can't even hold it open and push a button here and lock it. I have to go outside and lock it from the outside. Okay? And then I can lock the door, but then I come in and it's locked from the outside. Okay? I don't want you to hold it. Okay? All right. So that's that. Now, can't do much about this. So we turn off the light. Now, as soon as you hear the pop, 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 somebody, call 911 or campus police. Campus police probably heard it too. But guess what? They could be in that building or somewhere else, North Campus. They may not hear the pop, pop, pop. So call campus police or 911. Let's get that done. As soon as we know they've been called, turn those phones off. We don't want any vibrations. We don't want any noise of any kind coming out of those phones after we are sure something's been called. Now we still have a problem, Houston. There's another entrance to the building. I mean, to our room here. There's this room and this room. And
Oh, we got it out the window then.
there's the door there. Here's the bad news, folks. I don't have a key to that other classroom door.
Oh, we got to go out the window.
No. That's, okay. All right.
We got to go that way.
Okay, wait. Let's stay calm here. Okay? I'm going over there, one of you can if you want to, and close that door to the hallway. Turn off the light. Now, this door does have a button here, and it does lock. But it locks from the inside, not from the outside. That does us no good. Do not do that. Do not lock this door. Now, this door would be fantastic if I had a key to it, because that has a deadbolt, and it's a solid door. Okay? But I don't have a key to it. The good news is, this door over here does have a button. Anyone looking? Okay? Okay. This does have a button.
Didn't know if they come down. We did,
It's locked from the outside, not from the see in and see us moving around in here, easy enough for him to shoot through or bust through the glass, reach in, unlock the door if you need to do that, or open the door from the inside. So what I do after I lock that door, I close this door. Now, as far as he knows, that was locked too. He sure can't see in it. He's not going to waste a lot of time. He's trying to find someone to shoot. Hopefully he moves on. I say he because most of them have been he. There have been a few women involved in that. We'll go ahead and close this door, but don't lock it. Lights are off, phones are silenced, and we are back here because we like you so much. Yeah, you're not moving.
I ain't moving.
Because if you're anywhere here, he can see in. Don't be here. Be over here. And even if he chooses to shoot, he can't get you because he can't shoot around the corner.
What if he gets through that door? Let's say he shoot that glass right there, right?
What's that?
He shoot that first door be locked, right?
Okay.
Just shoot that glass, and then he open that door, right?
Okay.
And you said you can't lock that solid door, so he getting through that door. Then now he has that window.
Okay. Okay. But the thing is, he probably is not going to waste time on an empty room and a room you can't see there's anyone in. It looks like it's vacant. If he can't get in, he's wanting someone to shoot. So if he goes through all that, that is a possibility, and tries to get in here, then I would not, if I were you, risk your life and limb trying to get out through the limbs, okay? Because we're 2 floors up here, and it's not a soft area to land on down there. If he does make it through here, you don't be a hero nor an idiot. Okay, I'll be. Okay, I'm not the hero. Because guess what? I'm 67 years old. My life is back this way. Your life's up here ahead of you. So let me be the one that does whatever it takes to get that thing off of him. Okay, to block him, to stop him, whatever it is. Y'all stay, get under desk, behind desk, barricade desk, whatever it is, on the floor, whatever. Put as much between you and him as possible. Let me be the one who addresses him.
If he come through there, I'm gonna let you go first. I'm not gonna see him let you fight him by yourself.
Well, if I can block the gun, then go for it.
Yeah, God forbid
Okay.
something happen to you.
If y'all want to get really gross about it, this is true. Okay, go for the eyes. Y'all know what Navy SEALs are, right? I wasn't one. Okay, but we did take.
I was about to feel better.
It wasn't that funny. Okay, now we did have on our ship. We escorted Navy SEALs back and forth across the Pacific, so they coming home from their duty or taking them to it. And I stood watches with some of them. And I was standing watch one night, and the quartermaster, he's the one that keeps the logs and that kind of stuff. He just loved talking to these Navy SEALs. He said, "I bet you're not scared of getting in a bar fight with it." He said, "No, I am." Because he said, "Our training is you be in control of the situation as much as possible. The last place I want to be is a bar fight because you can't control anything there. I'm out of there." Magnafall was just chaos. Magnafall was just devastated. He just knew this guy knew how to hurt people really bad. He said, "Yeah, but what if you're in a situation you can't do anything? You can really do some damage to the person." He said, "That's not my point. My point is to get out of there. And if something like that were to happen and I can't get away from him, the easiest thing to do is reach up and pop out an eyeball." He said it doesn't take any energy at all. Just pop it out. And while he's trying to figure out what to do with that, run it. Okay? And he said, if that doesn't work, he said it only takes about 16 pounds to pull off an ear. Hand it to him, run. Okay? He won't know what to do with his ear, So there are some things you can do. No, don't do it. Okay. Okay, so what I'm saying, if I'm trying to distract him, go for the eyes. You don't have to pop out the eyeball, scratch him so he can't see anything, or something like that. I don't care if we damage the guy. He's trying to kill us. Okay, but if you're trying to help back me up, do that. Okay, he can't shoot if he can't see. Okay, or it won't be very effective. So I'm sorry, I didn't want to get that gross since you brought it up. I told my Navy story. Okay. All right. And we stay silent. We stay back here in the corner until we get the word. Absolutely know that all is clear. Hopefully it will never happen. Okay? I hope not, but we have to know what to think to do. All right. Any questions on any of that stuff? Safety, syllabus, research paper, anything. Let's get to trigonometry, finally. All right. I think when we went through the syllabus, I told you we're doing Chapter 4, Chapter 5, Chapter 6. That's it. Chapter 4 is a huge chapter, long chapter, okay? 4.1 is radian and degree measure. Does anyone know what a radian is?
It's the half of a diameter.
Okay, it has to do with that. Yeah, it's okay. You're right on the money there, or at least awfully close to it. The radius is half a diameter. You're absolutely right. And a radian measurement is related to that radius. It's related. Say again? Pound two? Okay. Now that is a radian measurement. You're right. That's equivalent to 90 degrees. Okay? So that's just a radian measurement. What is a radian? We'll get to it in a minute, but it's a ratio. That's what a radian is. So RA, ratio, radian. Okay? We'll talk about what the ratio is, and it has to do with the radius. Okay? We'll get there. Degree, well, we don't know what a degree is too, except it's very small. 1 degree, 2 degrees, 3 degrees, 45 degrees, 60 degrees, 90 degrees. So it's a measure also. Okay? Radians are just written as pure numbers. Degrees always have a little degree sign. Same degree sign we use for temperature. It's just we're talking about angle. Okay. So our objectives in this section are to describe angles, use radian measurement, use degree measures, and use angles to model and solve some real-life problems. Now, sort of hidden in there, that they don't mention, but it's pretty important, is how do you go back and forth between radians and degrees. So we'll do that as well. Okay? So let's talk about angles. Okay? Now, the Greek word that this came from, trigonometry. Now, if you know much about Greek, metra means to measure. So that's a measure of triangles. That's what it means. The measurement of triangles. The TRI is from the Greek word that meant triangles. I don't know what gomini is, but this is the measurement of triangles. And initially, the trigonometry dealt with the relationships among the sides and the angles of triangles. Okay? What is an angle then? It's, picture this. Picture a fixed ray. Okay? Has an endpoint, and it could be infinite there or finite there, it doesn't matter, but it has an endpoint. And then it moves from there, but the endpoint doesn't move. It rotates from there to somewhere else. The amount of rotation, that's your angle. Okay? An angle is determined by rotating a ray, which is a half line, fixed at one end, can be infinite at the other end, about the endpoint. The measure of your rotation, that's your angle. Okay? Now, the starting position of that ray is called the initial side of the angle. Now, it doesn't have to be, I put it horizontal to the right. That's the most common place. It can be here, it can be there, it can be anywhere. Whatever your initial side is, the fixed endpoint is called the vertex. Okay? The initial side is here, and however far it moves, where it stops, that's called the terminal side. Terminates, stops, ends. Okay? Initial, let's see, where it starts, terminal, where it ends. Okay? Now notice here, there's also sort of a measure of direction in here. It went from here to there. The same angle could have been here, but it's a different direction. Okay? So we'll get to that a little bit later. But that endpoint is called the vertex. They don't mention it on the slide, but that's there. I think it'll be on the next slide. Yeah, there it is. The endpoint of that ray is called the vertex of that angle. So, the perception of an angle, if you fit it into your normal Cartesian coordinate system, then our standard position for that initial side is the horizontal right ray from the positive x-axis. Now they draw this as a line segment rather than a ray. A ray would go infinite. This one sort of seems to stop. That's fine too. That's why I said it doesn't have to be a ray. So if that's your initial side, then this is your terminal side. Now remember, they don't have to do that way, but this we call the standard position. This is the easiest one to refer to. Okay? Now, there are several terms. I guess they're going to show it all to us. I was starting to do them now, but let's wait and see if they'll show them to us. Okay? When you're moving, and this seems to be backwards, but maybe we just built our clocks backwards. I don't know. Positive angles are counterclockwise. Negative angles are clockwise. So the sort of the positive here is positive, but counter sounds like it's negative. Negative here is negative, but that's clockwise. Okay. So just keep that in mind. You're probably aware of that anyway. Let's just see if you've ever run into this before. Here is your Cartesian coordinate system. You have a vertical axis and a horizontal axis. This splits the whole plane into 4 pieces. So we call them quadrants. Normally they number these quadrants. Which one's number 1? Upper right. What's number 2? Top left. Guess which way you're going? Counterclockwise. So we do the same thing here as we did there. Positive is counterclockwise, negative is clockwise. Okay. Now, I'm going to mention a couple things because we're here and they've got good illustrations of it here. This angle right here, we know it's negative, it says that. But this is called an acute angle. Does anyone know the definition of an acute angle? Less than 45 degrees? No, 90. Less than 90 or pi halves, as you were saying. Okay? This one's called what? Obtuse. And that's between 90 and 180 or pi halves and pi. Obtuse. If it was down here, then we'd say that's obtuse this way. Okay. So acute and obtuse. Now later we'll have other angles we'll deal with other names that are somewhat similar. We'll worry about that later. Now, angles are often given Greek letters, whereas a variable is usually a standard letter, English letter, X, Y. So we give variables for numbers, English letters or standard letters, but for angles we usually refer to them, not always, usually refer to them as Greek letters. Alpha, beta, gamma, but the favorite is theta. Everybody seems to want to call it theta. But there are other circumstances we'll call it capital letters, A, B, and C. Usually our variables are small letters. If you see a capital letter, that's usually referring to an angle. This is especially if it's a triangle. And you call this angle A, B, and C. Call this side A, B, and C. Okay, so but those would be little things. The sides would be, length of the sides would be a small letter. The angle would be the capital letter. Okay. Now, here's a couple of other names. If you have an angle with an initial side and a terminal side, that could be angle alpha, right? A positive angle. But guess what? That same initial side and terminal side could define this angle here, theta. This just happens to be negative, that one happens to be positive. That's not the only way you can have the same sides with different angles. Here's your initial side, here's your terminal side. This angle alpha describes that, right? But this angle beta does. It just went all the way around and then came back to here. That's also describing the same angle. Anytime you have two different angles described by the same sides, however you describe them, we call them co-terminal. They of course have the same initial side. They also have the same terminal. Co-terminal meaning the same terminal side. Now, anyone want to make a guess about what's common with these two? They don't look very common, but they do have something in common. This one's pretty obvious. What's the difference of angle beta to angle alpha? Well, the angle beta went up here but didn't stop, went all the way right around, but then stopped the second time. Say again?
Same degree, a radian.
Okay, okay, close. It went more. It went a full circle more. How many degrees or radians are in a full circle? Huh? Well, it went one time extra. And how many are in one? Say again? 360 degrees or 2 pi. 2 pi radians. So the difference between these two coterminal angles is 2 pi or some multiple of 2 pi. 360 or some multiple of 360. Now, is that true here? Which one do you want to start with? Alpha or beta? I don't care. You pick. Beta, okay? Starting with beta, okay? I'm going to say that beta is, I'm just going to make a guess here, negative 135 degrees. I'm just making a pretty good estimate there, negative 135 degrees, okay? What do you reckon would happen if I had added 360 to that? 360 plus 135, negative 135. Well, there's the negative, there's positive 135, and then that's the rest of it. Yeah, I added a 360 to it, or added 2 pi to it, or subtracted 2 pi from this one, or subtracted 360 from that. So the sum or the difference of any two coterminal angles is always a multiple of 2 pi, or a multiple of 360, if you allow negative multiples as well. Okay? That's true about it. I jumped the gun on it. They're going to tell you that later, but I thought since they had such a nice picture there, let's use it. Okay? So, I'm trying to follow in the book too. And by the way, if I make a reference to a page number and it doesn't make any sense to you, it's probably because this summer I didn't teach 112 or 113. And one of my adjuncts was teaching 112, but she didn't have the new edition of the book. And I didn't have a spare one. I said, well, you can use mine, but please give it back to me at the end of the summer because I'm going to be teaching it in the fall more than likely. Oh, sure, I'll do that. Guess what? She didn't. Okay? I don't have the current copy of the book, but I did have the older edition. So if I refer to a page number and it's not the same as yours, that's the reason. Okay? So we've just covered that. Now we're at the top of page, and the page number is probably wrong, 263 or somewhere like that. Do you have a page number on yours? Or you got the book? That's all right. Okay. But it's radian measure. Okay? Well, I asked the question before, what is radian measure? Y'all have some really good clues on it. You can determine the measure of an angle by the amount of rotation. That's no matter what you're using, that's what it is. The amount of rotation from the initial side to the terminal side, whichever way you're going. One way to measure that is in radians. This type of measure is especially useful in calculus. And I hope that's where you're all heading, right? Please say yes, okay? So, you'll use radians almost exclusively in calculus. If you use degrees, then you have certain factors you have to multiply or divide by to make sure everything works. But in radians, everything works really well. So here is a definition of a radian. Literally, a radian, 1 radian, okay? Y'all were mentioning close to this before. Let's have a circle here, centered at the origin. If it's a circle centered at the origin, then any ray from the origin to the circle is going to be a radius, right? said before, half a diameter is a radius. Okay. Now, that's your initial sign, 1 radius long. You rotate up some angle, and you got a radius up here too. When you rotate it up enough so that the arc length here, that's S, the arc length here is exactly equal to 1 radius, that angle is 1 radian. So in other words, I wish they'd say this to begin with. They don't say it on the next slide or two. Here's what I wish they'd say. A radian is the ratio of the arc length to the radius. That would say it all. I don't know why they don't say that up front. So they first show you what 1 radian is and then talk about the other. It's the ratio of the arc length. Okay. What they call this is the central angle of the circle, and the measure of that central angle of the circle is the ratio of the arc length that's cut of that circle to the radius of the circle. So if it's down here, that would be less than 1 radian. That would be exactly 1 radian. This could be 2 radians over here, 3 radians about here, 4 radians. You know, you keep on going around and around the circle. Or, okay, well, we'll get to it. I'm so eager to jump ahead, but let's not. Okay. So here's the definition of a radian. Finally, they say it right here. 1 radian is the measure of the central angle theta. This is a weird way to say it. That intercepts an arc S equal to the length of the radius of that circle. That's what 1 radian is. So algebraically, and this says it far better, theta in radians is the ratio of the arc length to the radius. That says it all. Who cares what 1 is or 7 are or whatever? Any radian measure is the ratio of the arc length to the radius. Where theta is measured in radians. Now guess what? Radian is not a unit. We'll treat it like a unit. We'll put RAD, you know. But really a rad is a measure of some sort of light and radiation intensity or something. So we'll say rads, but in reality it's just a number. It's a ratio. Now why doesn't it have units? If you're measuring the arc length in centimeters, you better be measuring your radius in centimeters. And centimeters over centimeters has no units. It's a dimensionless quantity. So a radian is not really a dimension. It just describes that angle. Okay. It actually has no dimensions. Okay. So when theta is equal to 1, that means S is equal to R. So that's why it cuts 1 radius. Okay, now here we get to it. Picture your circle again. What you're measuring your arc length. Now, what do we sometimes call arc length, especially if you go all the way around the circle? What do we call it? Circumference. And what is the circumference of a circle of radius R?
The length of the whole circle.
And how long is it? Do you know that formula? Oh, yes, you read it, didn't you? Okay. Your arc length all the way around the circle is 2 pi r. Another formula for that could be pi d. You may remember that one, but remember that d is 2r. Okay, so 2 pi r. So guess what? If that's the circumference or the arc length of the whole circle, then what would be the angle of the whole circle in radians? It would be S, which is 2 pi r, divided by r. Did you hear that? R's cancel out. So what does that give you? 2 pi. So that's why 2 pi is what we call 360 degrees. It's the angle all the way around the circle. So if it's 2 pi all the way around the circle, what would it be halfway around the circle? Pi. And what would be a quarter way around the circle? 2 pi halves, exactly. And half of that would be?
2 pi over 10.
Yeah, pi fourths. You divide it half. Okay. Pi fourths. And that would be 45 degrees. Okay? So you see, you actually know a lot of radian measures already. they're usually, like you mentioned before, related to pi's. So most of the time, if you see pi in an angle measurement, you're in radians, folks, okay, because it refers to it. You don't have to have the pi's in there, but a lot of times you do. I like having pi's. I love pi's. Okay, never mind. Think in terms of food. Now, 2 pi is about, pi is about 3.14156, it goes on forever. So they rounded to 3 digits and said about, pi would be 3.14, 2 pi would be about 6.28. So that means you're just over 6 radii, or radius lengths, around the circle. There's 1 radian, there's another radian, there's another. See, it stops 0.14 short of here, okay? Then another 4 radians, 5 radians, 6 radians. You need just about 1/4 of a radian to make it all the way down, okay? So just in general. Now, what if you took the entire circle? Now, let's go back to degrees, because you're probably more used to that. How much is around the whole circle? 360. Divide that by 6, and what do you get? 60. 60 degrees is just past 1 radian. So 1 radian is around 57 and a fraction degrees, or something like that. This is ballpark. A radian is a little less than 60 degrees, okay? For when you have to do these conversions, they're not mentioning degrees here. I shouldn't be either, but you're used to degrees, so why not? Because the units of measurement for S and R are the same, if you're measuring the arc length in inches, you better be measuring the radius in inches. If you're measuring the arc length in kilometers, you better be measuring the radius in kilometers, okay? So the ratio S to R has no units, it's just a real number, dimensionless quantity. But we usually stick the term radian at the end just to let people know what we're talking about. 7 what? 7 radians. Oh, you're talking about angles. Okay. Now, we just did this a minute ago, but I could do it visually first. Because the measure of the angle 1 full revolution is 2 pi r divided by r is 2 pi. 2 pi radians, 2 pi is just a dimensional quantity. Half a way around is pi radians. A 1/4 of the way around is pi half radians. A 1/6 of the way around would be 2 pi divided by 6. That would be pi thirds. There it is, 60 degrees. Okay. Make sense? Let's see if they do a few more. Here's the illustration of that. Let's start with this one. All the way around the circle, that angle is 2 pi. How are we doing on time? Let's see you check over. Time to go. Go, Griffin. Okay. Sorry. We'll have to begin here next time. Okay? Let's see if we got far enough along that you can do any homework exercises here. You might be able to do 7 or 9. And we did mention quadrants, but we haven't talked about it in class, so we'll just leave the rest of those for next time. Okay? I think you could have done them, but okay. All right. We'll do those next time.